Hello and welcome everyone. I will be trying to solve this problem called Make It Zero. Um, in this problem, you're going to be given an array. It's going to have including some level of numbers. What you have to do, your ultimate goal would be to convert each an element to zero. So an array having n number of elements, the elements can be of any number, but your ultimate goal would be to make it all to zero. And what are the possible operations that you can do in order to um, get the value zero for all the elements is you can actually select a subarray, and you would apply the XOR operation, bitwise XOR operation, and whatever the value of that XOR of that subarray is, you will replace each and every element of that subarray with the executed XOR bitwise operation, and you will replace that. So that's the thing. Now, there are some constraints. The constraint is that you are not allowed to use the operations above at more than 8 times. So within 8 times, you're going to have to apply this. And it's also said that it's always possible to make it within 8 operations at most. What you mainly have to do is just print how many operations that it took you to come up with the ultimate goal of making every element equal to 0 of the array. So it's actually always possible. You don't even need 8 times. I'll show you what what are the possible worst cases that you can come up in, and which way that we could solve that it would give us it would not take more than 4 operations, I guess. What's the solution then? Well, the solution is, you see, let's imagine we could actually divide the problem solution into 2 parts. What if the n given the given elements, the number of elements of the array is even. If it's even, then it's simply straightforward. The solution is simply straightforward. What would you do in the worst case? In the worst case, what you would do, or your solution would always be, okay, you will take your subarray as the whole element of the array, and you will apply the XOR operation, whatever. Let's say the XOR operation is X after you apply the subarray, meaning from 1 till n, in the even numbers, even number of total number, if the total number of element is even. So for the number of elements, if the number of element is even, what am I going to do? I'm going to XOR every element, whatever the value is, and apply the operation, which means apply the XOR and then apply again the subarray. Let's imagine the worst case. Let's imagine that this x is not equal to 0. I mean, if it's 0, then it's always the answer, but I'm talking about the worst cases. What are the possible worst cases? So if the number of element is even, whatever the XOR value is, if it's not equal to 0, I'm going to apply again the same thing, apply the XOR, but this time it's going to be 0, because same number, if n is even and every element is equal, the prefix XOR, or should I call it the XOR of that subarray, would always be 0. Why? XOR and XOR of these two will be 0, and if you apply these two's XOR, it will always be 0. So 0 XOR 0 is equal to 0. Even more explicitly, if I say 1, let's say 2 bitwise 1 1 0, what would happen if the two numbers are same? 1 and 1, if you do XOR, it's 0. 1 and 1, if you do XOR, 0. Similarly, let's say 0 and 0, if you do XOR, it's 0. So it's always going to be 0. And if the number of elements are even and they're equal, the XOR would always be equal to 0. So for the even case, the answer will be 1n and 1n. So I have two options that I will apply, 1n and 1n, taking the case of the worst case. So that's going to be for the even part. But what's going to be the odd length? But because I'm not going to be able to apply the same thing for the odd as I did for the even. Why? It's because the number of element is odd number. If I do take a very how do I call it, simple example. Let's imagine that I have only, let me see. Let's imagine that I have only 3 elements. Simplify the problems. Let's say I have only 3 elements, or let's just take 5. 3, 4, 5. Okay, now it's not even, it's odd. I cannot do the same thing that I did for the even. So in terms of odd, what you would do, you would simply divide the array into 2 parts. You would just divide it into 2 sections. And what you would do is you would XOR these first section of subarray, whatever the number is. Let's say the number is x, and this number, let's say it's y, whatever it is. Let's say it's y. Now, the number initially was odd, but when you perform the subarray, not taking the last element, what are the number of elements then? The number of elements are even, which means you have the x after you perform the first operation, which means 1 and minus 1. After you perform it, you have x. Let's just place all those x here. Now if I apply again 1 and n minus 1, what am I going to get? 0, just like what we did for the even part. So let's just replace all the x with the 0. Now I have all the elements of equal to 0. Now my goal is to make every element equal to 0. I still have got y left, which is a non-zero. I'm imagining the worst case, which is a non-zero. Let's imagine. And all of these are 0. So what I would do now is simply I will perform again another operation, but for this subarray. Okay, only the last 2, only the last 2 elements for an odd number of elements, and if there's an odd number of elements in the array. After I apply the XOR operation, now what am I going to get? I will get the XOR as y. Now replace every element with y. Did you get y? Yes, y. Now here it will always also be y. Now we have an even number of elements of the same value. I'm going to apply again the n minus 1 and n. The previous operation was also n minus 1 and n. So now if I apply, what's going to happen? 0. Then replace it 0 with this. So I hope you do understand what I'm trying to say. So in the worst case, for the odd number of elements, what will be the total worst case number of operations that I can use? First, it's going to be 1 and minus 1. I will apply the subarray. Then I will apply again, because I have to replace every element with 0. That's for odd, actually. If the total number of element is odd, the answer will be 1 and minus 1. 1 and minus 1. N minus 1 n, and n minus 1 n. Do you get my point? At most, within 4 operations, I can make each and every element 0. What about for the even? If the total number of element of the array initially is even, then the answer will be 1n and 1n. That's very, very simple. It's going to be 2 times. Now that's exactly what I did in the code section. It's basically the constructive one, so code is just as simple as it can get. As you can see, exactly what I said that I would be doing. So well, in this section, I also actually considered if the number of elements are already equal to 0 or not, but I actually don't need this condition. I could just easily apply and code this section. It would also give me accepted. I don't know why I did this, but I actually don't need it. So yeah, I think that would make sense. What I actually, let me briefly explain exactly what I did. I actually calculated whether the I actually don't need these two things too. I just unnecessarily coded here. If the element if the total number of element is even, I would simply the answer is 2 and this whatever I said. If the number of element is odd, then the answer will be always this, and this would give me the final answer. That's how I'm gonna just solve this problem. I hope you did understand it. Um, yeah, thank you for watching.